Hi, today we are looking at section 8.2, which is exploring graphs of periodic functions. So these are functions that repeat with a specified pattern over and over again, and we'll primarily be looking at our graphs of sine and cos. So we'll look at some definitions first. Periodic functions are functions whose graph repeats at regular intervals or cycles. The midline is a horizontal line located halfway between the maximum and minimum values of a periodic function. Our amplitude is the distance from a midline to a maximum or minimum value. Now, if a period is the length of one cycle. Now, I'll talk about everything that we just had in terms of this periodic graph here. So our midline is a line that goes straight through the center of our graph. So in this case, if I was, let's say, to draw a dashed line here, we can see that our graph goes 5 units above it, 5 units below it. So this here would be our midline. We then talked about amplitude. So amplitude would be the distance from here to here or from here to here. So in this case, this graph has an amplitude of 5 because it goes 5 units above our midline and 5 units below our midline. Now our period we can get by looking at the distance between two consecutive peaks or two consecutive troughs. So this we could measure to get our period. We can also measure this to get our period. Now for periodic functions, we'll be dealing with y equals sine x and y equals cosx. They have the following in common. They have multiple x-intercepts. They actually have an infinite amount of x-intercepts because our graphs will continue forever. They each have exactly one y-intercept. They have a domain of x is all real numbers. Now, if we don't have a number in front of sine or cosine to cause us to have a change in amplitude, our range will be from -1 to +1, which gives us an amplitude of 1. Now, depending on if we're graphing in degrees or radians, we have a period of 360 degrees or 2 pi. Now, if you're graphing on a graphing calculator, you need to make sure you're in the correct mode when you go to graph these, or your graph will look either stretched or compressed horizontally. Now, unless we have some sort of transformations, we'll have a midline of y equals 0. Now, our graph of y equals sine x looks like this. Now, I currently have this in degrees, but it essentially looks the same thing in radians, except for this would still be 0. Instead of 368 repeating, that'd be 2 pi. So half of that would be pi. Half of that would be pi over 2. Over here would be 3 pi over 2. This would be negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So you can see that we have a wave that repeats over and over. And like I said, it essentially has the same shape whether you are in degrees or radians. You just have to make sure if you're graphing on a calculator that you use the correct mode. Now our graph of cosx looks almost identical, except for our graph of cosx is being shifted. You'll see that on this graph, an x value is 0, our y value is 0. With cosine, an x value is 0, our y is 1. Now this once again was written in degrees, but we could also do it in radians. So that'd be negative 2 pi, negative 3 pi over 2, negative pi over 2, pi over 2, pi, 3 pi, over 2 and 2 pi. And you'll see we have a amplitude of 1. Our midline is at 0. We have one y-intercept, but we have many x-intercepts. Now, if we are graphing on the Texas Instruments graphing calculators, to select the correct mode, whether it's radians or degrees, you're going to press mode on your calculator. Then you'll scroll down, highlight either radian or degree, press enter, then press the second and quit to leave the menu. Now, if we want to change our domain and range or window, we'll do that just like we have with our regression equation. So we'll press window and then enter our minimum and maximum values for x and y.